Okay, so here's where we left off in class. Now we're going to talk about a triangle where you are given information about a triangle, and there are actually two triangles that will work with that same information. There could be two triangles that have an angle of 29 degrees, the side across from that angle being 7, and another angle being 10. So this is what we're going to find out here while we do this without really knowing what the triangle looks like. So I'm just drawing a generic triangle here because they're not always going to give you a picture. So I'm drawing this generic triangle where I've got A, B, C. Little b is the side across from big B, little c is the side across from big C, and little a is the side across from angle big A. So I'm just going to do this like I normally would with the law of sines. I'm going to fill in the values first, though. I'm going to put 29 degrees here, and little a is 7, little b is 10, and that's all I know. So I'm going to use the law of sines, sine 29 degrees over little a, which is 7, is going to equal sine of angle B over 10. And if I cross multiply, I've got 10 sine 29 degrees is equal to 7 sine B. Divide by 7 on both sides. And you get that sine B is equal to that fraction. And if you punch that into a calculator, you're going to get about 0.6926, which means that inverse sine of 0.6926 is angle B. Now, there are two angles that have the same sign, one in the first quadrant and one in the second quadrant. You know that from your unit circle. Sine is positive above the x-axis, so there are acute angles that have the same sign as an obtuse angle. So that is what we have to deal with when we're talking about triangles, because triangles can have first quadrant angles, acute angles, and they can also have second quadrant angles, obtuse angles. So when you punch this into your calculator will give you the first quadrant angle. It will give you the acute angle. So if you hit 0.6926 and hit inverse sine, it's going to give you about 43.8 degrees. But 180 minus 43.8 degrees is another angle that will have that same exact sign. That's 136.2 degrees. So the thing is, what is B? Is it this or is it this? Well, it could be either one, because all we have so far is 29. And if you add 29 to 43.8, that's perfectly fine. You're not going over 180 or anything. And if you add 136.2 to 29, you're not going over 180 either. So there could be two different triangles with these specifications, and we have to find both of them because it says solve the triangle. Well, there are two triangles to solve, and we have to do that. We have to find angle C and side C for both of these triangles. So if B is 43.8, that's what we'll start with. And we'll go ahead and find C and little c. So to find C, all we need to do is 180 minus 29 minus 43.8. And if we do that, we're going to get 107.2 degrees for C. So that would be our big C. And then to find little c, we're going to have to use law of sines again. So we'll say sine 29 over 7 is equal to sine 107.2 over little c. Cross multiply, little c times sine 29 is equal to 7 times sine 107.2. And if you divide both sides by sine 29, sine times 107.2 sine equals divided by 29 sine, depending on how your calculator works. And so that gives us a value for little c of about 13.8. So big C and little c, in that situation, you have a triangle where big B is 43.8 degrees. You've got big C is 107.2 degrees, and you've got little c is 13.8. So that's one possibility. The other possibility would be if you had B being the angle 136.2. So we'll go back and change B to 136.2 and see what we get for C and little c. So 136.2. First of all, to find big C, all we need to do is subtract 180 minus 29 minus 136.2. And if we do that, you're going to get about 14.8 degrees for C. So we would have C is 14.8 degrees. B, we're saying, is 136.2. And now we just have to find little c, which we'll do by using the law of sines again. And you get about 3.7 for little c. And so that would be the other answer for this problem. There are two triangles. When we have a triangle that has a side and then an angle and another side, we can derive a little formula for the area of any triangle like that. And we can do that using sines. So we know that the area of a triangle is equal to base times height over 2. If we drop the height down to the base, we create a right triangle. And we can say that sine A, is equal to opposite over hypotenuse. So h over b. And if we multiply both sides by b, we will have b sine A is equal to the height. And so base times height over 2, the base in this case is c. The height is b sine A. And then over 2, usually it's written 1/2. So that's just a little formula for the area of a triangle if you have an angle with two adjacent sides that you know. Okay. To estimate the height of a hill, the angle of elevation is measured at 2 points 480 meters apart on a direct line to the hill. The angle of elevation from the closer point is 42.1. If the angle of elevation from the farther point is 32 degrees, find the height of the hill. So we're trying to find the height of this hill. It's not an easy subject to find the height of because it's got a irregular shape, and the height is kind of like inside the hill because it goes up to the highest point. So it wouldn't be easy to figure out the height of this, but this is one way to do it. And so you could just stand at two different places, in this case 480 meters apart, and measure the angle of elevation to the top of the hill, and then figure out the height. And the way you're going to do that is by finding the hypotenuse of one of those right triangles. So we can find the hypotenuse, either one, by working with this little skinny triangle right here. We've got a side and we've got an angle, and we actually have another angle because we know that 42.1 and this angle right here create a straight line. So they must add up to 180. So that angle right there has to be 180 minus 42.1, which is 137.9. So that's what that angle is. So remember, to use law of sines, you have to have a pair. You have to have an angle and the side opposite to it. Well, we don't have that yet, but we can find this angle very easily just by subtracting both 32, this angle, and 137.9 from 180. So 180 minus 32 minus 137.9. And that's going to give us 10.1 degrees for this little bitty angle up here. So 10.1 degrees. So now I can use my law of sines to find either of the other sides. I'm going to call this side little a and this side little b. I'll just find little a. Why not? Okay, so the angle across from little a is the 137.9. Sine 137.9 over little a is equal to sine 10.1 degrees over 480. So cross multiply 480 times sine 137.9 is equal to little a times sine 10.1. And then if you divide by sine 10.1, and you get about 1,835 meters for little a. So now I have that hypotenuse, and I can find this side, which is the height of the hill. So I'm going to use sine. So sine 32 degrees is equal to opposite over hypotenuse, multiply sine 32 by 1,835, and that's going to give you y, which is about 972 meters.